Hello guys, my name is Piros and today we're going to talk about the Outbox pattern. We'll see what it is, what problems it solves, and how to implement it from scratch. So let's begin by taking a look at what problems it solves. Okay, let's say I have two applications, two microservices if you want, the Heroes app and the Villains app. Now a request comes from a user to create a hero, and in our Heroes app we want to save the hero to database and then publish an event, a hero created event, to a message broker, and that message broker will finally forward that event to our Villains app. So for example, we want to create a hero with its hero name and its real name, and in our Villains app we don't care about the real name because the villains should not always know about the real name of the hero, so we pass only the ID of the hero with its hero name. So now what problems that implementation has? Okay, let's say we are here in our Heroes app, we save the hero to database and then we publish that event. Now what will happen if we fail to publish that event? Let's say our message broker is down or something else. We will have our hero in our Heroes database, but in our Villains app we will not have that hero, so our system will be in an inconsistent state. And that will happen the other way around. If, let's say, first we publish that event and if that succeeds, and then the call to the database fail, we will have a hero in the Villains app and not in our Heroes app. So the system will be again in an inconsistent state. So that's where the Outbox pattern comes in to solve these problems. Let me show you what I mean. So now again we receive a request to create a hero, but instead of publishing the event when we handle the request, we save the hero to the database and we also save the hero created event. And that thing over here will be an atomic operation, so it will happen in the same transaction. So either we save both the hero and the hero created event, or we save none of it. So now we have the hero and the event. And now we also have a background service that checks the database for events and it publishes it to the message broker. So eventually, sometime even if our broker is down, when we came up again, since that's a background service that runs all the time in the background, the event will be published and then the hero will also be created in our Villains app and our system and the system will be in a consistent state. And since we are in our drawings, let me show you something else. Now we finally published that hero created event and our message broker forwards that message to our Villains app. And let's say we have two handlers to handle that event that do some different operations. Now in that Villains app we can handle that in two different ways. We can say that both of our handlers, in our example 2, will handle the event in a single transaction, so or both of them will succeed or both of them will fail, so we will not acknowledge the event and we will try again. Or we can say that those two operations are different operations. So for example, if the first succeeds and the second fails, we will still not acknowledge the event, so it will eventually come back again, but then the second time we receive that event, the first handler will not run since have already run and did its job, and only the second one will run. There are other things to consider, for example, receiving the same event twice, etc., and we will see all that in our code. So now let's jump into our code. So I have in my solutions a Heroes application, and let's see what it does by following the create hero request. So in my program.cs I add the mediator, I also add DB context, I have hard-coded the connection string for simplicity purposes. Then I add two services, one of them is hosted, we will see those in a second. And then I have a post endpoint in which I receive a create hero request, and then I send the create hero command. If we go into our create hero command, we can see that all we do is create a new hero we add it to our DB context, and then we save the changes. Now if I go inside my hero, as you can see, it implements an iHasDomain events interface, the contract to implement a pubDomain events method which returns a list of iDomain event. My iDomain event implements the iNotification of Mediator. You don't have to have your domain events implement iNotification to publish them with Mediator. I have a video about that, but I'll use it for simplicity in that demo. So when we create a hero, we add the new hero created event. That event implements the iDomain event and has a hero ID and the hero name, since we don't care about the real name of our hero. Okay, so we will save it to the database, and now you might ask, okay, you save it to the database, where do you save? I don't see any saving of the event. Actually, if I go in my DB context inside of my save changes async method, as you can see, I have override the save changes async of the DB context. So in here, when I try to save an entity, I check if there are some entities that implement the iHasDomain events, and then I take all the domain events. Then I create a queue of domain events in which I put every domain event, and then I call a dispatch events async method, which if I go into it, I just take the events one by one, and then I publish them with Mediator. So that event has two handlers. I will go to my application folder, and the events, the one is a hero created event handler, and I just log some information that has nothing to do with an integration event. It's just a part of my application, another handler, because we can have a lot of event handlers. Now if I go to my infrastructure project, in my integration events, I have an Outbox integration event handler, which also implements the identification handler of the hero created event, and that could implement the identification handlers of a lot of other events that we want to have as integration events. And in here, all I do is I create a new hero integration event. We'll see what it is, and then I add it to my DB context. So now when we come to actually save the changes in our database, we will have our hero and our integration event. Now you don't have to do that inside of the save changes async method. There's a lot of ways you can do that. We can do that as part of the HTTP request pipeline, as part of a Mediator pipeline. We can have an interceptor on the DB context. I'll just have it here for simplicity. And now let's go to see what our Outbox integration event is. So if we go in here, we can see that our Outbox integration event has an event ID. We will talk about the ID of the events and the idempotency in a second, the event name and the event content. And if you can see here, I serialize the event for the event content. So that will be a GUID, that will be a hero created, that event name will be a hero created event, and the event content will be the hero created event serialized. It will all make sense in a second. So okay, now I have my hero and my hero created event in the database, and then let's see how we publish, how we can publish that event. Let me close all tabs and go to my publish integration event background service. It's just an iHosted service, and in the background I have a delay of 6 seconds, so it will run every 6 seconds. Then I create the scope and I get the hero DB context, and then I take all the integration events. If I don't have any, I return, but if I have, I iterate through them, and then I get the integration event by deserializing the event content of my integration event. And I can do that because my integration event, as you can see, it is decorated with a JSON derived type, so it knows how to deserialize that as a hero created integration event. We will see what that looks like in the database when we run our project. Now I also use a wrapper for my integration event, and we will see that again in a second. And then I use my integration event publisher, publish event async method to publish that event. So in that point we have publish our event. Then I remove those events from my DB context, and then I save the changes. Now let's see why we want that wrapper. That's a simple integration event wrapper that I created. It has the integration event itself and the event ID that we take from the database. You can use something else with more details or the cloud event specification. But that simple wrapper, it is good enough for example. So what happens if we are here, we publish our event, and then that call to the database fails. We will have published our events, but our application won't know about that since we still have them in our database. So the next time that this method runs, we'll also publish those events again, and we will have duplicate events. And that's why we have that integration event wrapper using the event of the ID, so that the systems that will consume our event will check the ID, and if it's an ID of an event that they have already consumed, they will ignore it. So now before we do anything else, we can run that heroes app, make a request, and see that even we don't have a message broker at the moment, or our villains app is down, we will have that integration event in our database, and it will be consumed when everything is up. But before that, let me show you what is inside the publish event async method. I use RabbitMQ for my message broker. I just initialize a connection factor. I have hard-coded all the values. Probably you would inject you will inject some options instead of hard-coding all of that. But anyway, just publish that event. So also let me show you, I have a Docker Compose YAML file in which I have RabbitMQ and my database. I will just run my database, and we will leave RabbitMQ down to simulate that our message broker is actually down. So let me run that. Okay. So let's debug our application to see what will happen. I'll open Postman. I'll have a request with the hero name Spider-Man and the real name Peter Parker. I'll send the request. We created Spider-Man, and we can also put a breakpoint in here. And you can see we have two integration events. One is from a previous call that I made. Okay, and if we call that publish event async, we will have an exception because our RabbitMQ is down. But if we go to our database and check, let's check first for our heroes. We have the same hero twice because I made two requests. Let me remove one of them. So we have our Spider-Man with the real name Peter Parker, and now in our Outbox integration events, again let me remove that first event. We have that event because we weren't able to publish that, and it has the ID, the event name, which is hero created integration event, and the event content. And as you can see in the event content, we also have the type of the event, so our application now knows how to deserialize it to the right type, and everything works as expected. So now when finally our message broker is up, we can consume the event from the other services and have a system in a consistent state. Now let's see what's in our villains app. Let me close all these tabs. Okay, in my infrastructure I have my villains DB context, which has only DB set of consume integration event, because we want to keep track of the events we consume, so we don't consume the same event more than one time. And my integration event, I have a consume integration event background service, which all it does, it's listening for events from the heroes integration events queue. Nothing fancy about that. And now when it's time to consume that event, we come in that consume integration event method, in which we deserialize the event to that integration event wrapper that we previously saw, and we call the dispatch async method of our dispatcher, which we will see in a second, and then we acknowledge that we received and processed that event. And if everything fails, and if something fails, we will not acknowledge that event, so it will come back again, or it will go to a dead letter queue, but in one way or another we will receive that again. So let's go inside that dispatch async method of my dispatcher, and it receives an integration event wrapper, and let's see what it does. It gets the integration event from that wrapper, then take all the handlers that are responsible to handle that integration event, and then for each of this one handler I call the check and dispatch async method. And let's see what that check and dispatch async method does. But before that, let's take another look to our consume integration event. And as you can see, it has an event ID and the handler. So as we saw in our drawings, we will handle that in the way that we have a lot of handlers for an event, and we treat them as separate parts of our workflow. So if we receive an event and we handle them in one handler, we will write to the database that that event is processed by that handler, and if another handler can process it, we will not acknowledge the event will come again, and when it comes again, we will have that record that that event for that handler has been processed, so we'll ignore it. So now back to our dispatcher. We get the type of the handler, the ID, and the method, because we want to invoke it later. So we check in our DB context if in our consume integration events we have anyone with the same ID and with the name of that handler, and if we do, we return. We don't want to do something we have already handled that event with that handler. Then I begin a transaction and I have a try catch block in which I invoke the method of our handler, and that handle can make changes to our database. So I use transaction because after we call that handler, that as we said can change the state of our database, I also add to my consume integration events that a consume integration event with the ID of the event and the name of the handler, so we'll have a record that we handle that event. So we want these two operations to be an atomic operation in the same transaction, and then I save the changes and I commit my transaction. If something will go wrong, we will not have commit anything. Probably we could have a rollback in here, but it's okay. And finally I dispose my transaction. So now let's put some breakpoints, and actually let's start from the start so we can have both applications running and see all the flow. So I'll debug my heroes app, I'll debug my villains app, and let's check the database from our Outbox integration events is empty. I delete all the events. So I'll open Postman again, I'll send the request now. So that happened very fast. We weren't able to see that event in here, but we saw that flow the previous time. So now we take our handlers. We have two handlers, here created event handler and here created event handler 2. I didn't show you those handlers. Let me do that. I'll go to my VLanes in my applications folder, and I have a here created event handler that does anything, and a here created event handler 2 that throws an exception. So back to our dispatcher. We will have for the first handler, we'll get the type. The type is here create event handler. Then we'll get the integration event, the ID, the method. We'll make a check to our database if we have any record with that event ID and the here created event handler name. we want. So we'll go and invoke that event handler. So let's run again. And now for our second handler, that will throw an exception. So let's go in here. And when we try to invoke it, it will throw that exception. So we have an exception. And now if we check in our database in the VLANs app in the consume integration event, we'll see we have the event ID of the event and the handler hero created event handler. So the next time that we try to process that event, that handler will not be invoked since we have already invoked that and we have a record of that in our database. And finally, if we go to our RabbitMQ UI, we can see we have our heroes integration event queue. And we have one unacknowledged message because we didn't acknowledge it because the second handler threw an exception. So that was the Outbox pattern. I just show you what it is, what problems it solves, and how to implement it. I didn't code along since it was a lot of code and that would make a video very, very long. I'll just show you the important parts on how to handle that events. If you want to elaborate more on a specific part of all that flow, please let me know in the comments below. If you like this video, please like and subscribe. Thank you for watching and have a nice one.